Alrighty, hello everyone. Thanks for being patient with me as I got everything set up. So we'll go ahead and get started for today. I realize you guys cannot see my screen because I forgot to share screen. Let me do that super quick. Okay, awesome. So today we're just going to be practicing a lot of the concepts we learned last week because Vieta's formulas are super important and there's a lot you can do with them. So it's important to understand like how you can kind of manipulate the formulas to get a lot of different results. So that's our goal for today, to be working a lot on different kinds of problems. I hope you'll find them challenging enough. But before we get started, we'll go ahead and do a quick icebreaker. I am starting to find it very difficult to come up with enough icebreaker questions, just because like I am doing separate icebreakers for like the geometry class and the algebra class. And so like it is hard for me to think sometimes. But if I ever like repeat an icebreaker, let me know. We'll come up with something else. Or if you guys have maybe your own icebreaker that you want to share one day, let me know and we will totally do that. Because it is definitely getting harder for me to come up with some new ones. So today's like pretty simple, pretty generic. What is your favorite hobby? So Aditya put in the chat karate, and that is super cool. What belt are you, Aditya? I used to do Taekwondo a couple years ago. I got my second degree black belt and then I kind of like didn't have time to continue. But it was good. I really do enjoy Taekwondo. I think it's a good sport. Amit says playing tennis. That's awesome. I also dabbled in tennis for a couple of years when I was like I would say like maybe in elementary school still. But yeah, tennis is cool. Tennis is cool. Viva, he says playing soccer. I did a soccer camp for like 3 months. But soccer is totally cool. That's totally, I think soccer is a cool sport. If I wanted to like, if I like was actually athletic, I think I would like learn how to play soccer because I think that's cool. Entity says second degree black belt. That's awesome. That's awesome. Me too. Me too. Amari says I also used to do Taekwondo. That's great. I feel like Taekwondo gives you like a lot of skills, like not just like physical abilities, but a lot of like mental abilities too. Like I always found it as a good brain break from like math and stuff. So this is like I do really enjoy Taekwondo. Oh, it looks like Dora also does Taekwondo. That's really cool. That's really cool. A lot of Taekwondo kids here. Adi says playing tennis and chess. Believe it or not, I also had a chess phase. Wow, everything you guys are saying are things that I have done, but I have not pursued, which I think is really funny. I think chess is cool. I feel like chess people are always so smart. And it's awesome. It's very good for critical thinking. Ashrith says solving Rubik's cubes. Oh, that's awesome. Um, I could solve a 2 by 2 cube, and that is about it. I cannot solve a 3 by 3 cube. But I'm highly impressed that you could solve Rubik's cubes because like learning those algorithms and stuff is like totally crazy. But Rubik's cubes and chess too, they're all very like connected to math. So I think it's very interesting to see like that parallel. Doris says swimming competitively. Wow, I wish I could have swim. I have so much respect for swimmers. I know how to swim. I used to take swim lessons and everything. But like competitive swimmers, I have so much respect for because like they have like crazy practice times. Like they're always competing and like they'll be swimming in the dead of winter at like 5 in the morning. I'm just like, that's crazy. But yeah, I think swimming competitively is awesome. Dora says reading as well. Yeah, I love to read. Actually, it's really interesting. A lot of people have only said like sports answers so far. I haven't really seen a lot of like other answers, which is interesting. Zombie says swimming. Amari says comics and soccer. Yeah, comics are super cool. I used to read a lot of comics when I was younger, and then I kind of like grew out of it because I couldn't find anything good anymore. Vivehi says I do every sport. I used to do every sport when I was a kid. And to be clear, like I did sports for like maybe 6 months before I decided I hated it and quit. But yeah, I did not follow through on the sports. I think my favorite sport is probably like Taekwondo. I do enjoy that a lot. Manit says playing Roblox. Awesome. You should do something active, Manit, instead of being in front of a computer. Jason says swimming. Awesome. Oh, Manit is also a first degree black belt. That's really cool. Really cool. Okay. Oh, and then Simhit says chess. Doris says chess as well. Manit says Roblox. Oh, again. Adar says, fun fact, today is World Octopus Day. That is a really cool fun fact that I did not know. Okay, thanks so much, Arthar, for sharing that. That's super cool. Uh, oh, Adar says, I could solve a 3 by 3 by 3 pyramid. Is that like the triangle like Oh, yeah, pyramid, right? So it's a pyramid. Wait, that's super cool. That's like actually really, really impressive. Wow. This shit says playing my guitar. Oh my gosh. Wait, that's so cool you can play guitar. I really want to learn how to play guitar. Because I feel like that's such a cool instrument. It's very versatile. You can play a lot, you can do a lot with the guitar. Ashra says, I like the Mega Minx, which is like the 12-sided. Okay, what even is that? Mega Minx? Wait, I wonder if you guys can still see my screen. Oh well. Oh my goodness, that's like outrageous. Holy cow, that's like a soccer ball Rubik's Cube. I don't even know how you move the things on that. That's crazy. And he says chess and math and taekwondo. Very cool, very cool. And he can also solve a 3x3 Rubik's Cube. That's awesome. Wow. You guys like with the Rubik's Cubes, like that's so crazy. Like that is actually really impressive. Wow. Someone says I could solve 3x3 too. Yeah. I can solve a 1x1 and a 2x2, as impressive as that is. Let's see. Athar says tennis. Oh yeah. Awesome, awesome. Okay, well, this is really cool. I think it's awesome hearing what your guys' favorite hobbies are. Totally lots of cool hobbies here. Jason asks, is there a 100 by 100 cube? Probably not. I don't really think there is. All right. Well, anyways, on that exciting note, let's go ahead and do some problems for today. Um, Okay, so like I said before, in case some of you guys are joining a little late, we are going to be doing a lot of practice problems. So just to recap, last week we talked about Vieta's formulas, which hopefully you guys were able to brush up on using the homework. And then today we're kind of going to apply them to different problems. So to start off, our first problem is going to be this. I think it seems like confusing, but just remember the tools that we have learned. And then I'll give you guys like a couple, maybe like 30, 45 seconds to think about this, and then we'll kind of move on and discuss a solution. But this is where we're starting for today. Okay, so I think we have some people that were not here last week. So while those of you that may have an idea on how to do this start, um, let's go ahead and talk about maybe some of the Vieta's formula. So do you guys remember how to find the sum of two roots? How do we find the sum of two roots? Yeah, Bishop says it's b over. Oh, wait. I think you guys are close. Double check. Double check your signs. Remember, signs are super important. So the b over a part is correct, but because we're taking the sum, it's going to be negative b over a. Yeah. Yeah, yeah, yeah. There you guys go. Okay, good job. And what about the product of two roots? And I guess I'll write this in a different color. Yeah, that's gonna be C over A. Perfect. Um, Product of two roots is, oh man. Okay. And the nice thing about Vieta's formulas are they're like really intuitive. They're very easy to derive. So if you ever feel like you're forgetting the signs or something, just think about like the factoring of a quadratic, which is typically like x minus m times x minus n. And think about how the product of the roots and the sum of the roots relate to the coefficients of the quadratic. But yeah, this is like something you guys really should remember because this comes up a ton, and you don't want to have to rederive it for every problem. So I would recommend you remember this, but if you like are confused about where these are coming from, check out the lesson from last week on YouTube. And there we kind of go through like the crazy quadratic formula proof that we did. But yeah, these are the formulas that are like pretty important. Okay, so let's go ahead and apply to this problem. Yes, on YouTube. I have been uploading all our recordings on YouTube for you guys to check out if you need to rewatch anything. Okay, anyways, I don't see any answers just yet, so let's go ahead and do this first problem together, and then maybe we can kind of figure out a path going forward. Do I have subscribers? I don't think I have any subscribers. You guys are welcome to subscribe, but I really don't care. As long as you guys are getting some use out of it, that is what matters to me. Okay, I do see Minnie's answer of 9x squared minus 45x plus 54. Okay, awesome. So that's one potential answer. Um, Amari says, what is the channel called? I think it's literally just Bridge2Math. I have to double check. It should be in the email I send out every week. We always send out the YouTube link. But yeah. Okay. But I bet he says I got roots of 1 and -6. Okay, I like this path of like maybe starting with the roots, right? So let's say we factor this. So x squared minus 5x plus 6 factors into X, can we factor this? Yes, we can. Vaivehi, I would actually disagree with you. I would disagree with the roots that you got. Yeah, so right now Amari, we're trying to find the roots of this equation because that seems like something we can possibly do. You guys can use quadratic formula, but I think this is, no, you're all good. You guys can use quadratic formula, but I think this is something we can do by observation. So what do you guys think will kind of go in these blanks? What do you guys think? What numbers? So, okay, yeah, some hits says 2 and 3, which I agree with. And a couple of things about the signs here. We know that these both have to be negatives because the product is positive. And remember, two negatives multiplied together gets us that positive sign. Also, the reason why they're negative and not just two positives is because we have this -5, right? So that means like there has to be some negative number multiplied by x. So that's why it's -2 and like -3 here. Okay, so our roots are x minus 2 and x minus 3, which means that x is equal to 2 or 3. Okay, so that's the values that we plug into this equation to get 0. So that's where that all comes from. Okay, perfect. So now that we have the roots, and I guess like we'll say like r is equal to 2 and r is equal to 3, right? So can you guys say what, oh, wait, no, not r, sorry. This should be s. My bad, my bad. I totally confused everyone. Oh no. Okay. So like obviously 3r is 6 and 3s is 9. Like this is not crazy math. You guys know how to do this. Okay. And I do see an updated answer from Manit of x squared minus 15x plus 54. So let's go ahead and check out if that is right. Actually, Manit, do you want to explain how you got that?
So first, you can just quickly see that you get 2 and 3.
Okay.
Isn't it supposed to be -2 and -3 as the root?
Close. Okay, so here we have the factors x minus 2 times x minus 3, right? And that's equal to 0. So if x minus 2 times x minus 3 is equal to 0, that means that either x minus 2 is equal to 0 or x minus 3 is equal to 0, right? So for this entire equation to equal 0, x is equal to 2 or x is equal to 3. Make sense?
Oh, yeah.
Okay, perfect.
So like I got x squared.
Mhm.
Like so when the roots are 2 and 3, you just multiply both by 3, which would make 6 and 9.
Perfect.
So then what you can do is you do x. So if the root is 6, that means it has to be x minus 6
Good
times
work. Yeah.
x minus 7.
I think you mean x minus 9, right?
Yeah, x minus 9.
Okay, no, you're good. You're good.
So when you solve that, I'm pretty sure you're getting x minus 15 plus 54.
I think you meant to say x squared minus 15x
Yeah,
plus
x.
54. Yeah. I know what you mean though, because that's what you put in chat, right? Okay. And I think Vaivahi agrees with you, and I think Jason does as well. Yeah, I think so. Okay. Perfect. Oh, and Samhith does as well, and Nahal. Okay, perfect. Glad to see we are kind of on the same page. And Ashra then Vishith. Okay, awesome. Good work, you guys. Okay, so this is totally one way of approaching this, right? But there is a lot of work here. Like first we had to factor the quadratic, and then we had to like multiply and then like multiply this entire thing out, which is like it's not hard. Yeah, Samhith says it's not hard. But what happens when you cannot factor this, right? Then you may like turn to quadratic formula. And then you may get some like crazy square roots and fractions. And then if you try to triple that and multiply it, like, man, that is just gonna get straight up messy, right? So let's say like we had a pretty messy quadratic. Well, in that case, we don't want to factor. In that case, we don't want to find the roots. So if we don't want to find the roots, but we still want to find some relationships with the roots, let's see what we can do, right? I like this idea of Manit doing like x minus the 3 times something and like x minus the 3 times the other root and then kind of going from there. But let's say like we don't know what r and s are, right? So instead, and I'll do this in orange, we'll have x minus 3r times x minus 3s. So this is how we can represent that new quadratic, okay? This is not any different from what Manit did down here, except we don't know what r and s are. That's why we're leaving it in this form, okay? So go ahead, take a second and expand this orange expression and let me know in the chat what you get. And we'll kind of talk about that. Okay, and then Jason, let me take a look at your picture really quick. Wait, what does one do this? Okay, let's take a look at what everyone is saying. Okay, so I see an answer from Anvika, which is, hold on, this is very interesting. Okay, I'm seeing x squared minus 3rx minus, I think that's meant to be, I think that's 3sx. I see 35 for some reason. Okay, hold on. Let's see what everyone else is saying super quickly. Um, Okay, yeah, 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 yeah. I think, yeah, I agree with what Mini. Oh, wait. Yeah, 9RS. There we go. There we go. Yeah, perfect, perfect. Okay. Yeah, yeah, yeah. Good. No, okay, yeah. So it looks like my S is like a 30, is like a 5. Okay, no worries. Anvika, I think you're still like on the right path. I just confused you. So let's see. I will write S. I will try to make my S's really obvious, and my fives will like, I'll try to make them look sharp. But yeah, sorry, my handwriting like kind of sucks with this stylus. That's okay though. Okay, and it seems like we all kind of agree on this. Okay, so this is just like simple FOIL. So nothing crazy. Okay, you guys got negative 3sx. Oh, wait. I agree with what Oshrit has put in the chat. I think I agree with that. Yeah. Yeah, yeah, yeah. Okay, so that's what I agree with, right? So once we'll just FOIL this out super quickly. So we'll do the first terms multiply together, that's x squared, and then we'll do the second term, or we'll do the outer terms, right? So we'll do x times negative 3s. So that'll give us negative 3sx. And then we'll do the inner term, so negative 3r times x is negative 3rx. And then multiplying the last terms, we get negative 3r times negative 3s. So the negatives become a positive. Any negatives multiplied together becomes plus. 3 times 3 is 9, and then r times s is just rs, right? So this is the final expression. Okay, this is neat, and I can kind of like group the x terms together, right? So I'll do like x squared, and then I'll kind of do like, I guess like minus 3r plus 3s times x plus 9rs. Okay, how does everyone feel about this? Okay, Sumit feels like God. He feels like God after this. Well, I'm glad you feel that confidence on it. No, I know you meant good. I'm just messing with you. But yeah, okay, good. I'm glad we're on the same page. All right, so I think some of these are pretty familiar, right? Like 3r plus 3s is like seems pretty familiar from something in here, and I feel like we know how to find rs as well. So, can you guys tell me like, first of all, like, what is r plus s, right? Because I feel like that'll help us find 3r plus 3s. So what is r plus s based on this original equation that we have? Careful, Samhit. Remember, look up here for like the sum of the roots at the very top in green. Yeah. Okay. Okay, Bhavit says Vishith and Nahal and Anvika and Samhith. Okay, yeah, I'll say 5. Perfect. So r plus s is just 5, right? Because we know from this purple equation, the sum of the roots is just negative b over a. In this case, b is negative 5. So negative negative 5 is 5 divided by 1. So r plus s is 5. What about r times s? What is r times s? 6, yeah, perfect. And that's just the last term divided by the first coefficient. So that's just 6 over 1. Okay, and now this is really easy, right? We know r plus s is 5, and we're looking for 3 times r plus s. So if we plug that in, we'll get 15. So our final thing becomes x squared minus 15x. Oops, my 15 like sucks. Okay, and then that last term is 9 times rs, and we know rs is 6. So 9 times 6 is 54, and this will be, oh my goodness, that was so anticlimactic, you guys. I'm so sorry. My line like totally sucked. Okay. Yay, and that's our final answer, right? Okay, so I feel like this one didn't, okay, so first of all, like this approach is better in my opinion because we didn't have to find the roots, which is like really nice in case the roots are not as like friendly as 2 and 3, right? Because sometimes you get like some crazy square root stuff and this is like not ideal. But in this case, I would say like without finding the roots, we're able to find out what like this entire quadratic is, right? Because we can easily find the sum of the roots and the product of the roots. And so that's where this comes from. Okay? So how do we feel about this? Does this make sense? Sort of, Samhit says. Bobbitt says yes. Benit says yes. Okay. Samhit asks, how did I get 54? Okay, good question. So we know like this last term is 9 times rs, right? Based on the original equation, we know that r times s is obviously the product of the roots, right? So that's just going to be 6 over 1. So rs is 6. And if we plug that back into this equation, 9 times rs, that's going to be 9 times 6, which is 54. Okay? Yes. Okay, that makes sense. Perfect, perfect. Yeah, and then the negative 15x will come from, okay, so we have negative and then 3r plus 3s, right? We know r plus s is 5. So to get 3r plus 3s, we just have to multiply this 5 by 3. So that's where we get the 15 from, right? And so you just get the 15x and don't forget the negative sign. So negative 15x. Okay, perfect. And yeah, okay, I think we're all kind of getting it now. Good, good. Okay. And yeah, so for Dora, the 5 and this, oh, I feel like I messed something up. I definitely messed something up. Oh my goodness. I'm so sorry, you guys. My writing totally got cut off. Wait, how does one fix this? Okay. I will try to fix this while I'm talking. But anyways, the 5 and 6 come from Vieta's formulas, which are listed at the top up here. But yeah, okay, perfect. Wait, I feel like okay, this is fine. Um, cool. All right. Is everyone good with this? I think, you know what? Okay, actually, hold on. It does not matter if you're good with this because we will do more questions and you will get better with this. So let's go ahead and do a couple questions. I will still leave Vieta's formula up here, but at some point in the class, I'll probably take it down because this should be like, you guys should know this. It's also not a difficult thing to remember. So yeah. Okay. Okay, I don't want to move to fractions just yet, so we'll do another problem of this type, and then we'll kind of like look at some more advanced things. Okay, here we go. So this is like another pretty similar question. So let's go ahead and practice with this and make sure we are all on the same page. Okay, I see an answer from Manit that is x squared minus 8x minus 12. Let's see if anyone else. Oh, the plus. Okay. Oh, I see now. Okay, because the shift. Yeah, yeah, yeah. Makes sense. Okay, I thought that was just like minus. Okay, Samhit agrees. Nahal agrees. Cool, cool, cool. Vaivehi agrees. Okay, awesome. Let's go ahead and take a look at this question. Yeah? Okay. Uh, color. I don't think I've used red yet. Okay, let's use some red. All right, so to start off, I'm not going to factor it this time. You guys are more than welcome to try it that way. Instead, I'm going to go straight into x minus 2r times x minus 2s, right? So when we go ahead and multiply this out, we'll get x squared minus, and then I'll do 2r plus 2s times x plus 4rs. Is everyone clear with where this expansion comes from? I'm not skipping any steps for everyone. We're all on the same page here. Yes? Okay, lovely. So now let's go ahead and figure out what r plus s is. Well, we'll just go ahead and use Vieta's formulas. We know the b term is 4. So we'll get negative 4 over a, which is the coefficient of the first term. In this case, it's just 1. So r plus s is negative 4. Okay, we also need to find rs, right? So rs is going to be the last term divided by the first term. So 3 divided by 1, coefficients, right? So rs is 3. Perfect. So when we go ahead and plug into this previous expression, we will get x squared minus, I guess I'll do like 2 times negative 4x and then plus 4 times 3. Okay, so this is x squared plus 8x plus 12. All right, and I think that's what you guys all said, so I just want to double check, is everyone good with all these steps? Meanwhile, let me check. Okay, Minnie asked for a challenge problem, which we will definitely get to some pretty challenging problems. The next one is like, I feel like it'll incorporate some fractions. So it'll be a little more difficult than this, but not super. And then the last question. Oh, wait, I think one of the last questions we'll do today is like hopefully pretty challenging. Maybe you've seen it before, but I hope it's challenging. Okay, Vibehi asks, we're using Vieta's formula instead of quadratic. Yes, that is absolutely correct. You can factor this without quadratics formulas. The reason why I want you guys to be comfortable with this approach is because sometimes your roots are not very like friendly, meaning they're not integers, so it's hard to work with. This case like assumes regardless of what your roots are, it's very easy to solve for. Okay, and then let's see. Sorry, you guys, I'm just like catching up. I'm super slow. Okay, awesome, awesome. You guys are all good. You feel comfortable now. Where do we use the Vieta's formulas finding the roots? Yeah, so Vieta's formulas actually skips over finding the roots and tells us about like the sum and product of the roots, which is really nice in case we have like some very messy roots with square roots and fractions. So yeah, Vieta's formulas are good for finding sums and products based on the coefficients of the original quadratic equation. Okay, good. I think we're all on the same page now. Yeah, and Manit has kind of summarized like the method we used here. So this is good. Very good. Thanks, Manit. Okay. Um, yeah, so because we want to find the quadratic equation whose roots are 2r and 2s, we can kind of create the factors x minus 2r and x minus 2s. Because if like, let's say x is equal to 2r, this becomes 0. And if x is equal to 2s, this becomes 0, which means that those are the values that are the roots or the solutions to the equations. So that's why this is our factoring. So what we then go ahead and do is we expand this factoring to get this like new quadratic. And from there, we can very easily find r plus s and rs based on the original quadratic. Okay, amazing. I think, oh, and then thank you, Audie, for also putting in an explanation. I didn't see that originally. Okay, cool, cool, cool. Wait, I feel like I'm just rereading all of the same text. Okay, maybe it's because you guys like put questions and I just wasn't looking at. Okay, Bishop asks, shouldn't the negative 8x in the equation? No, because in this case, remember the product of the roots is going to be the last coefficient divided by the first coefficient, right? So that's just 3 over 1 or 3. And we just do 4 times 3, which is 12. Oh, I think you mean this middle term. My bad. Hold on. In this case, the sum of the roots is negative 4 over 1, so that's negative 4. And then we have like this negative of 2 times negative 4. So that's where this comes from, right? So negative 2, negative 4, that becomes positive 8. Okay, perfect. Let me just triple check and make sure everyone's good. Sorry, you guys, that it took me some time to get to your questions. My apologies. Okay, yeah, we did not find roots at all. That's what makes this method really nice. Okay. Yay. I think you guys are all on the same page now. Okay, this is really wonderful. Let's go ahead, take it up just like just a tiny notch by including some fractions now, but fundamentally like the problem is still the same. Yeah, it is easy, but it sounds really hard. Because we are still like Yeah, yeah. Actually, that's a good way of saying it. It does sound easy, but is um or it sounds hard, but it's actually easier than it looks once you understand the trick. Okay, let's go ahead and take a look at this next question. Okay, perfect. So we'll go ahead, take some time here. Again, you're pretty much using the same methods, just a little extra complication with that fraction. Okay, I am starting to see some answers in the chat. They are both a little different, but that's okay. I also see one question from Ashrith with which is, would the original question factor be x minus r times x minus s? Yes, yeah. So if you're factoring this first quadratic up here, yeah, it would be factored into x minus r times x minus s because that's what the roots are down here. Yeah, that's absolutely correct. Okay. Cool. Oh wait, I'm just kidding. It seems like, okay, never mind. It seems like we all kind of have similar answers. All right, let's go ahead and take a look, yeah? So in this case, we have x, oh man, I already used green. What a struggle. Okay, we'll do orange, I guess. Okay, so we have x minus r over 2 times x minus s over 2. Yeah, color doesn't matter. I just hate using the same colors over and over because like that's like it's just boring. So this is like more for me than you guys. Okay, so let's go ahead and expand this. We get first terms is x squared. Inner and then outer terms we'll get negative r over 2 plus s over 2 times x. And then last terms multiplied together, we get rs over 4. Okay. So what is r plus s in this case, in this quadratic? Yeah, it's just one, right? Because the original b term is -1, and then the a coefficient is 1. So negative of -1 divided by 1 is just 1, which is pretty simple. Okay, what about r times s? What is r times s? Yeah, it's oh wait. Okay, you guys, it's okay. I know that r plus s is 1 now. Thank you though for all your help. Yeah, okay. Now r times s is going to be -6, right? Because it's just the last term, -6, divided by the coefficient of the first term, which is 1. So that's going to be r times s is -6. Okay, so then we just go ahead and plug it back into this equation. So the final quadratic equation is x squared minus 1 over 2 times x plus -6 over 4, which we can simplify this to -3 over 2. So I'll go ahead and erase this and do -3 over 2. And that is our final answer. Okay, what do you guys think about this? Is this good? Anviti says, I got the same answer, but I just multiplied the whole expression by 2 to limit the fractions. Yeah, you can totally do that. You can do that because like essentially like their roots are still the same. So it's like kind of the same quadratics. But yeah, that works. Okay. Cool. Yes, I got something different. Okay, Bobbitt, double check your work because I think everyone kind of agrees with this. If you're confused on like maybe one of these steps, let me know and we can go into it a little more. Okay, Um, Isn't it plus one half? No. Yeah, it would not be plus one half. So in this case, the product of the roots is just -6 based on like this sign over here. And because in this case, like the expanded expression, we have RS over 4, right? So RS is -6. So -6 over 4 is -3 over 2. That's where that comes from. Yeah. Oh, wait. Oh my gosh, wait. I always keep looking. Man, someone always asks me about the middle term, and I always tell them about the last term instead. Okay, that's totally my bad. Okay, Bobby got x squared plus x plus 1 over 2. Okay, I think your signs are definitely a little off. So check your signs. Um, because once you get to this point, it's very much just like plug and chug each of these values here. So that's not the hard part. Just make sure you get like this original expansion. Yeah. Okay. Um, okay. Yeah, so I'm seeing a lot of people asking for recaps. So let's do a quick recap, yeah? Um, yeah, we'll talk about where the -1/2 x comes from. Okay, so basically what I'm doing here is I know I have like a mystery quadratic equation, and I know the quadratic equation has roots r over 2 and s over 2. So if I put this in like a nice factoring form, I get x minus r over 2 times x minus s over 2. Is this good for everyone? Yes. Okay, awesome. So now what we're doing, we're just doing a little bit of FOIL and expanding this out. And when we do that, we get x squared minus r over 2x minus s over 2x plus rs over 4. Okay, so you guys can clearly see like the x squared and the rs over 4. What I've done is I've condensed the negative rx over 2 and the negative sx over 2 into this one term, right? So I factored out the x, pulled out that negative sign, and inside my parentheses, I just have r over 2 and s over 2. Okay, so now once I have this, I can very clearly see this r plus s over 2, and I can very clearly see this rs, right? So that tells me, let's use some Vieta's formulas. I can clearly see r plus s from this quadratic is negative of -1 over 1, which is just 1. And rs is, r times s is just -6, right? So -6 divided by 1. And when we go ahead and plug this up into this equation, we get x squared minus, and then we know that r plus s is 1, right? So 1 over that denominator of 2, so -1/2 times x. And then here we get the -6 over 4, so -3 over 2. Okay, so that's where that final answer comes from. Hopefully that method like cleared it up for you guys. Um, yeah. Audie asks, I changed the R over 2 and S over 2 into 1 over 2R and 1 over 2S. Is that fine? No, because what you're, oh wait, okay, well it depends. Do you mean like 1 divided by 2S or like 1/2 times S? Because if it's 1/2 times S, like that's fine. That's the same thing as S over 2. But if it's 1 over 2S, like we have a little bit of a problem. Okay. Cool. Samhit gets it. Bhavik gets it, I think. Yeah. Awesome. Ashrith gets it. Great. If we foil, Adora asked if we foil this thing, we will get the same answer. Um, I'm not understanding. I'm not sure what the question is, right? Because if we FOIL this, we're getting something that's a little different. Because remember, the roots of the original quadratic are x and r. So that can be like x minus r times x minus s. But the quadratic we want is x minus r over 2 and x minus s over 2. So that's where that comes from. Okay, and Viti says that was helpful. Adi says great. Rohan says that makes sense. 1 over 2 times s. Adi, yeah, that's correct. You could do that. Yeah. Okay. Okay, perfect. Okay, good. All right, I'm glad we're all on the same page. So let's level it up a notch. I hope we can do 2 more questions. There's 2 more types that I want to cover. Hopefully we can get to both of them. That would be super awesome. But I think this is pretty clear. So you guys understand like how to deal with situations where you're finding a quadratic where the roots are like multiplied by a certain factor. Even though we did something with fractions previously, I don't think it makes that big of a difference, right? Because all you're doing is just multiplying by like something that's less than 1, which is like fine. What we're doing now is we're taking this up a notch and adding some addition, and this can get a little bit tricky. So there's two ways that I would suggest approaching this problem. First, you can use the approach we did before where we like found the factoring method or like found the factors, foiled it out, and then kind of plugged in the R's and S's. The second way is you can go ahead and find the sum of the roots for r plus 2 and s plus 2, and the product of the roots for r plus 2 and s plus 2, and then kind of construct the quadratic from there. So see if you can figure out either of those methods and see if you can come to a final answer, and then we'll kind of talk about how to do this overall. I think for this question, I'm going to actually remove the Vieta's formulas because I feel like this is like, you guys should know this by now. Okay. Also, we need the extra space, that's why. Okay, and Beatty says x squared minus 10x plus 24. Looks like Minnie agrees. Alrighty. Let's take a look. Okay, Nahal also agrees. Awesome. Okay, seems like Samhith agrees. Nice. Okay, this is really good, you guys. Ashra says, can I write my equation as x minus r plus 2 and x plus s plus 2? Ashra, okay, that first answer is fine. The first factor is fine. The second one, it should be x minus s plus 2, not x plus. But yeah, otherwise you can write it like that. Samhith says, I closed chat and turned volume off. Did y'all get the same answer? Yes. Oh wait, I guess he can't hear me. Maybe someone could reply to Samhith and let him know that he's okay. Yeah. Okay, good. Um, okay, and it looks like Jason also agrees. Awesome. Perfect. Okay, I wonder if maybe Anviti would like to unmute and share how they got to x squared minus 10x plus 24. Because I think you were one of the first people to get it.
So I use like the quadratic formula solution. I didn't like use Vieta's formula. So
Okay.
like I kind of solved for the roots first, and like I
Okay.
didn't really need the quadratic formula. I kind of just like factorized it out and like got it.
Okay.
So I got x minus 2. Wait, I'm gonna let you. Yeah, x
Yeah,
minus
thank
2
you.
times x minus 4, and
Perfect.
then I solved my roots to like get x equals 2 or like 4.
Okay.
So then that means like r plus 2, so that would be like 4, and then like s plus 2, that would be like 6.
Perfect.
So then like from there, like since like my roots are like positive, I have to like make my sum like negative. So
Mhm.
I did like x minus 4 and like x minus 6, and then I multiplied those two to get my answer.
Yeah, and then you get x squared minus 10x plus 24.
Yeah.
Perfect. Thank you so much, NVT, for
Mhm.
unmuting and sharing that. Okay, now once again, this approach works 100% fine if your roots are integers. Let's prepare for the case when your roots are not integers. Okay, so in this case, that's when we want to use quadratic formula. So I think it was Oshrit that initially suggested like, can we do x minus r plus 2 times x minus s plus 2. And to that, I would say, like, yes, you can do this and expand it out and do some FOIL and stuff. But I will say, like, this gets pretty crazy, right? Because now we have, like, we're multiplying by, like, two terms that have three things in them, which can get, like, pretty chaotic. So to kind of reduce the work here, I would say let's find out what the sum and product are and then kind of construct the quadratic from that, right? So let's find the sum of the roots, r plus 2 and s plus 2. What is r plus 2 plus s plus 2? What is this sum? Yeah, that's just r plus s plus 4, right? So nothing crazy there. All right, now let's say we had r plus 2 times s plus 2. What is that equal to? This one's a little trickier because you got to do some FOIL. Yeah, rs plus 2r plus 2s plus 4. So thank you, Audie, Nahal, and Vika, and some hit as well. Okay, perfect, right? So this is what we get. And I think we can evaluate these based on our original quadratic. So from the original quadratic, we can say that, I guess I'll use some blue. We can say that r plus s is equal to negative of -6/1, right? So that's equal to 6, okay? We can also say RS is equal to 8/1 or 8. Okay, so that's where this comes from. We know what R plus S is and what RS is. So then we can say R plus S plus 4 is just 10. That's pretty simple substitution. And this mess down here is 8 plus 2 times 6 plus 4, which comes out to be 24. Okay, is everyone good with that? Does everyone see where that occurred, like where that comes from? Yes, yes, yes. Okay, good. I see lots of yeses. This is awesome, you guys. Perfect. So now that we have this, we're kind of going to reverse construct our quadratic equation, right? So we're going to start off with this like x squared term. And then we have this, like, we know the sum is 10, right? So if this sum is 10, that means the b term has to be what? What does the b term have to be in order for the sum to be 10? And then Audie, I'll come back to your question at the end. I see it, and I will come back to it. But in the meantime, if the sum of the roots is 10, the b term is -10, like Bobbitt says. Yeah, that's absolutely correct. Good work. So yeah, this is going to be -10x, right? And you can kind of like think about the Vieta's formulas again, right? Because we know the sum of the roots is negative of the b term divided by the first coefficient. So negative of -10, that's 10. So -10x is absolutely correct. Okay. So what is the last term if the product of the roots is 24? What would the last term be? Okay, Enrica says 24, and I totally agree with that because in this case, remember, the product of the roots is just the last term divided by the first term, right? And we already know the product is 24, the first term is 1, so that means this last term is just 24. And it looks like some have kind of got to the same answer as well. Okay, perfect. So this is another way of kind of coming to this solution, okay? I did see a question from Audie about where we get r plus 2 and s plus 2 from. And the reason why we did this is to find the sum of these two new roots, so that way we can get back to like this original quadratic equation over here, okay? So I know this approach is a little bit different because we're not doing this FOIL stuff. And the reason why that is because FOIL gets messy. But like fundamentally, we're not doing anything different. Like we're still finding the r plus s and the rs, and we're still substituting back. It's just we're like reverse engineering our quadratic equation. Okay, awesome. By FOIL, I mean we're not expanding this product out, this gigantic product. Okay, cool. Okay, okay. I see a couple of questions. So let's do some questions. Let's answer these. So Bava asks, okay, Bava says this is confuzzling. This is confusing. Bava, where did I lose you? Where did you get lost? And then yeah, okay, let's look at that and then I'll come back to Dora's question. Okay. Okay, so I know like there is a lot going on here. There's like 5 different variables, so that can totally be intimidating. What I will say though is like all we're doing is just applying Vieta's formulas like 20 different times, okay? So to start off, we're looking at our new roots of this equation, r plus 2 and s plus 2. And that's where we do like, to find the sum of these roots, we get r plus 2 and s plus 2. So we add those together and that gets us 10 based on like what we know with the rest of the stuff, okay? And then we kind of do the same thing finding the product of the roots. R plus 2 times S plus 2 gives us this stuff, which comes out to be 24, okay? So we get 10 and 24 are the sum and product. Now remember, Vieta's formulas are really nice, right? Because they relate all of the coefficients of a quadratic to the sum and product. In this case, we don't know the coefficients of the quadratic, but we know the sum and the product already. So if we know the sum and the product, we can kind of work backwards to get to the original quadratic. So that's kind of all we're doing here. We're just applying Vieta's formulas multiple times and then like kind of reverse engineering to get back to the quadratic equation. Okay, hopefully that cleared up the process for everyone. And yeah. Okay, let's go ahead and do one last question. I think we have time for one last question. I wanted to do one more of this type, but I like the last question more. I think it's far more interesting. So we'll go ahead and do that instead. Um, okay. Give me a moment. All right. This I will say is tricky. Maybe you guys have seen it though, because this is like a pretty popular like mathleague.org question. Yeah. Okay. I do see a lot of side chatter going on, which is okay. I know you guys are getting this pretty quickly. This question I would recommend you guys focus on because it is definitely a challenge problem, I would say. Okay, and if it helps, I know like this x1, x2 stuff is like kind of crazy. So we'll do R and then R and then S and then S. Okay, great. Okay. Manit says this is not possible. Manit, you are partially correct. You cannot find the roots x1 and x2 easily because they are, I think they are imaginary or they're like square roots. They're like messy, basically. So yeah, this is one of those situations where you can't factor this easily and then like kind of solve this just using your factoring skills. Like you have some pretty weird stuff going on here. And so this is where I say like this is a prime example of how Vieta's formulas are useful. And I know I don't think we're gonna have time for like you guys to all figure this out and then like talk about it afterwards. So we'll kind of walk through this step by step together. Um, oh yeah, sorry. I like changed these variables so that way like you guys wouldn't get confused with x1, x2 because I feel like that's hard for me to write and that's hard and annoying for you guys to read as well. Okay, yeah, cool. All right, so if you guys want to solve this on your own, like go ahead, you guys can start doing that. For those of us who are like totally lost, that's okay. We'll start on this one together because I do want to finish this before class ends. So, starting off with, I think we should expand these. I think expanding is the right way to go, right? So let's say we do r minus 1 over r squared. What does this come out to be? Go ahead and expand this for me. And think back to um, our squares formulas, our squares formulas that we did at the beginning of this class. Okay, perfect. So Jason says r squared minus, I guess we can simplify. Oh, well, I'll do this for like making sure we're all on the same page. Plus 1 over r squared. Okay, perfect. And it seems like Nahal agrees, so thank you both for putting that in chat. Yeah, this is what we get, right? You can do this with FOIL, you can do this with our scores formula, pretty simple stuff. So this comes out to be r squared minus 2 plus 1 over r squared. Okay, everyone good with this? Yes. Wow, I see so many caps. Amazing. Okay. Um, Tanvi says, I agree. Nahal says, from where? I'm not sure what that means. Nahal, if you want to clarify. Ashrith says, yes. Samhith says, that's correct. Okay, good. Yeah. Atharv says agree. Vishit says agree as well. Okay, lovely. So we're all on the same page. Okay, so now let's do the same thing for s minus 1 over s. It's the same thing again. We just FOIL this out or use our squares formula. And this comes to be um, s squared minus 2 plus 1 over s squared. It's the same thing here because these are the exact same thing except just s instead of r. Okay, yeah, so basically what we're doing is we're going ahead and expanding each of these expressions. Yeah, Jason, I think I understand what you meant with the equal sign. You're all good. Yeah, okay. Yeah, good, good, good. Um, okay. Good. Is everyone clear like how we're expanding this? R minus 1 over r squared. Okay, think back to our first class, you guys. This is definitely stuff we have talked about very early in the class. This is just like our squares formula, like a minus b whole squared. That's all we're doing here. This is a squared minus 2ab plus b squared. That's all this is, except we have a is r and b is 1 over r. So that's why we can simplify that middle term as 2. Okay, that's all this is. Do not overthink. Okay, good. So now that we have that, let's go ahead and add these together, right? So we get r squared, and I guess I'll have to do this in blue. R squared minus 2. Well, okay, hold on. We'll do r squared minus s squared. So that's one thing. And then we'll do, oh, I guess this is plus. Okay, and then we'll do 1 over r squared plus 1 over s squared. And then we'll do minus 4. Okay, so all I did was combine both of these expressions. I just added things together. Okay, now here's where the tricky part comes from, right? I need to find r squared and s squared. I do not have that immediately from Vieta's formulas, but last class we kind of discovered how to get r squared plus s squared, right? What we did was we did r plus s whole squared, and that's going to be r squared plus 2rs plus s squared. Okay, so we did this, and then we see the r squared and the s squared, so to get that, we just have to subtract 2rs. So we bring that on this side, so r plus s squared minus 2rs is r squared plus s squared. I know I'm rushing a little bit just so that we can get to the end of class, so if something's like off about this, go ahead and rewatch the recording. But really quickly, does everyone see how these are equal? Why these two are equal? No. Okay. First of all we're doing for up here, r plus s whole squared is this expression. We want to get r squared plus s squared, so we just subtract 2rs on both sides. That's where this comes from. Okay, perfect. So now that we have this, we can say like r squared plus s squared is equal to the sum of the roots squared minus 2 times rs. Okay, so pretty simple stuff there. And then we want to find out 1 over r squared plus 1 over s squared. Well, because we have unlike denominators, we got to do a little cross multiplication here. So we'll get r squared plus s squared in the numerator divided by rs squared. Okay, does that make sense to everyone? I do see a couple questions, so let me pause really quickly. Anviti says, is it 4? No, because remember, we're adding these two expressions, right? So there's a -2 here and a -2 here. So -2 plus -2 is -4. That's where that comes from, okay? Manit says he's a little lost in where the terms come from. So basically all we're doing through most of this problem is just expanding a bunch of squares. Manit says, how did we get 4? So the 4 comes from, remember, because we're adding these two expressions together, we'll get -2 plus -2. So that's where the -4 comes from. That's why there's the constant. Which 2? Remember, when we expand this, we have r squared minus 2r over r. And that simplifies to 2. So we get like that -2. That's where that comes from. Yeah, there you go. Okay. Yeah, that's the only constant, so we add those together. Yes, yes, that's right, Dora. Okay. And then the 1 over r squared and the 1 over s squared, those come from here, right? So we just add those together. Okay. Perfect. Good. Okay, I think we're on the same page now. So now we just go ahead and find the sums and products. So in this case, we can say that the sum of the roots, and let me use some red here. So the sum of the roots r plus s is just going to be 4. The product is rs1. Very easy by observation with Vieta's formulas. Okay, so now that we have that business, can you guys tell me what r squared plus s squared is using what we have found over here? What is r squared plus s squared? Ashrit says, would using a quadratic formula be faster? I would say absolutely not, because you get really messy roots with square roots involved. And then imagine having to take the square roots and then take the reciprocal and then take the square and then do that again for this. So absolutely not. Do not use a quadratic formula. And that's why we've been doing these Vieta's formulas questions, even for the previous ones, in cases like this where it's really hard to work with the roots. But yeah, good question. Okay. So yeah, r squared plus s squared would be 14 because we have r plus s squared, which is 16, minus 2 times rs. So 2 times 1, which is 14. Okay, so that's where this 14 comes from. So this is 14. And then now we have the 1 over r squared plus 1 over s squared, right? So in the numerator, we have r squared plus s squared, which we just found out is 14. Okay, so that's 14 divided by the denominator squared, which is 1 squared. So just 1. Okay, and then we have this -4 at the end. So we have 14 plus 14 over 1 minus 4, which comes out to be 24. And that is our final answer. Okay, perfect. And I think Bobbitt did this, so really good work. I know it's 9 o'clock, and I know I really rushed through that. So please go watch the video again to make sure you understand this. Nothing we've done here is like something you guys haven't seen before. Like this is stuff you've all seen before. These are all properties we've talked about before, all problems that we've solved before. We're just putting everything together to get like this one final answer. So yeah, that's where that comes from. Okay, looks like Anvika also got the same answer, so thank you, Anvika. And thank you, Ashrit, for sending that to me. Okay, perfect, perfect. Yeah, this is totally competition math stuff. Yeah, this is a hard problem. I do feel bad that I really rushed through this, because it is definitely a harder question. But you guys will get totally more practice with this in the homework, so don't worry if you're a little stuck right now. Yeah, cool, cool, cool. This is more like, okay. I'm just making sure I don't see any questions. Yes, I do design these problems, or like I pull them from like problems that I know are common in competition math. Like this one, so common in competition math. Like it comes up like all the time. So that's why I think it's important to understand. Okay. Cool. So it seems like Vashith and Nahala are getting these as well. Where do I get the homework? I make them just like I make the handouts. Yeah. Oh, and yeah. Oh, yeah. Homework comes through the email. Sorry, I didn't understand your question. Okay. Okay, perfect. Okay, so I think we're all on the same. I don't see any like major questions right now. So let's go ahead and end here. And if like, well, yeah. And if you're like still lost about this, rewatch the video because I promise it'll make sense if you see it multiple times. But yeah, everything is here. Okay, great. Thank you guys so much for joining me tonight, and thank you for staying a couple minutes over. I hope you guys learned something new. I hope today's class was challenging. And yeah, I hope you guys have fun doing the homework problems. Okay, enjoy your weekend, enjoy the rest of your week, and I will see you all next week. All right, bye everyone. Thank you so much. Thank you so much for joining. Bye Anvika, bye Nahal, bye Vashith, bye Samhith, bye Amari. Awesome. Bye Tondi. Bye Anviti. Bye-bye. Awesome. Okay. All right. Do you have any questions for me? Or are you all good? Okay, I'm gonna go ahead and stop for now. All right. See you everyone.